Hey everyone, today we are going to talk about graphs of relationships. So we are going to add another piece to what we've been working on. We started with identifying independent and dependent variables. How are those things related? How does that create a table? And then how do we write a rule for that table? So now we're going to add the final piece to that. So we're going to be given a rule. We're going to identify the independent and dependent variables. We're going to create a table of values, and then we're going to use that table to create the graph. So the first one says the equation A equals 126B represents the approximate number of apples A in B bushels of apples. Graph the relationship on the coordinate plane. So it tells me right here what my two variables are. I just got to figure out which one's independent and which one's dependent. The independent variable is the one that I'm putting into the function. So 126 times the number of bushels and then the dependent is going to be the total number of apples. I can see this in my equation because it's A equals, so this A is going to be apples, and then this B is going to be bushels, so the bushels are my input and the apples are my output. I can also see it on the graph down here. Remember that the x-axis is your independent and the y-axis is your dependent. Because I have to do the x before I can do the y when I'm graphing, so the independent variable is going to be the x-axis, the dependent variable is going to be the y-axis. So now when I create my table, I'm going to have the number of bushels first, the number of apples. So my ordered pairs are going to be B comma A, but this is also X comma Y. Because when I put it on the graph, it's going to be X-axis, then Y-axis. And you can see on the graph here, it's labeled B and A. When I create my own tables, I like to start with 0, because 0 is an easy value to work with, and I can compute or calculate easily with 0. 0 may or may not affect the function in any way, but plugging in 0 is always super easy. And then I'm going to go up by ones because the bottom of my graph goes by ones here. So 126 times 0 is going to be 0. So my first ordered pair is going to be 0, 0. 126 times 1 is going to be 126, so 1 comma 126. And then 2 times 126 is going to be 252. So this is going to be 2 comma 252. Then I'm going to come over to my graph. 0 comma 0 is going to be in the corner. Now on this particular graph, the scale is going by 20s. So 126 is not going to be perfectly on here, but I can estimate pretty closely where that 126 is going to be. It's going to be a little bit closer to 120. So I'm going to be like right here, because midway would be 130, and then over 130 would be closer to 140. And then 2 comma 252 is going to be pretty close to in between 40 and 60. These should form a line. We are graphing linear relationships. So because the pattern is the same, we should be forming a line. So I'm going to connect those with a line. Now the table has 3 spaces for 3 different input values. You only need 2 points to make a line, but we include that third point to show that our pattern is continuing. Part B says the equation C equals 2P plus 3 represents the total cost in dollars of ordering P pounds of personalized jelly beans. So I'm going to have the total cost in dollars, and then this is going to be pounds of jelly beans. I have to buy the jelly beans before I know what they cost. And I can also see down here pounds and cost, so I know that pounds is my independent and cost is my dependent. So I'm going to have pounds and cost, and they used P and C, which is the same as X and Y. Again, I'm going to start with 0, so 0, 1, 2. So here I'm going to do 2 times 0 plus 3. So this is going to be 0, comma 3. 2 times 1 plus 3 is going to be 5, so 1, comma 5. And then 2 times 2 plus 3 is going to be 7, so 2, comma 7. Now when I go to my graph on this one, these should be perfectly accurate because 0, comma 3 is on the graph, 1, comma 5, and then 2, comma 7. I could obviously continue the pattern for several values if I wanted to. You only need 2 points to make a line. I include the third one just to show that that pattern is continuing. So 0, comma 3, 1, comma 5, 2, comma 7. And then I'm going to draw my line. Part C says the graph shows the relationship between the cost to rent a canoe and the number of hours the canoe is rented. Write a function rule to represent the graph. So again, my independent and my dependent can come from the sides here. So the independent is going to be time in hours and then cost in dollars. So I've got time and cost, and we're going to create a table from the points that I see on the graph. So I've got 3 points here. 1, 2, 3. So we're going to create a table, and then we're going to use what we know about writing function rules to then write our rule. So I've got 1, 15, 2, 25, and 3, 35. So these are going up by 1s. And these are going up by 10. So my equation is going to start with y equals 10x, and then I'm going to make sure my rule works. So 10 times 1 is 10, and then I'm going to add 5. So 10x plus 5 is my rule. And that was given a graph, identifying independent and dependent, creating the table. So in the first one, we created the table from the rule. Now we're creating the table from the graph and writing our rule. Part B says Nathan constructed the graph that shows the height of his cactus after several years of growth. Assuming the cactus grows at a constant rate, write an equation from the graph. So again, my independent and dependent could be given on the graph here. I can also say that years is going to be my independent because time is always passing. And then it's going to be the height of the cactus as a result. And that height is in inches. So I've got years and height. And I'm going to use these 3 lovely points they have for me on the graph. So 142, 244, and 346. So plus 2, and then these are going by 1s. So I'm going to start with y equals 2x. 2 times 1 is 2, and I have to add 40 to get to 42. So my rule is going to be 2x plus 40. Okay, so on the back side here, in these 2 examples, instead of creating the table from the rule, I was creating the table from the graph itself and then using my knowledge of tables to create that function rule to represent the situation. Okay, so we're going to practice this a bunch and then take a quiz.